Hey everybody, Mr. Quick here. Welcome to Eureka Math / Engage New York Math, Module 4, Lesson 29, Multi-Step Problems. So again, what we're going to do today, or in this lesson, is very similar to what we did in Lesson 28, except for instead of two-step problems, we're looking at multi-step problems, so more than two steps. It's still a matter of breaking things down in a way that makes it easy for us to understand what parts kind of go together, right? And so it's ultimately getting to a solution. So let's go ahead and get started. Let's look at an example here. The school librarian, Mr. Marker, knows the library has 1,400 books, but wants to reorganize how the books are displayed on the shelves. Mr. Marker needs to know how many fiction, nonfiction, and resource books are in the library. So we're looking at fiction, nonfiction, and resource books, and he has 1,400. He knows that the library has 4 times as many fiction books as resource books, and half as many nonfiction books as fiction books. If these are the only types of books in the library, how many of each type of book are in the library? Okay, so I'm going to create some tape diagrams here, but the first thing I want to do is I want to start with just what do I know? So I'm going to erase a little bit just so we can read it a little bit easier. Read it a little bit easier there. Okay, so we know the library has 4 times as many fiction books as resource books. So let's just create a tape diagram, and we'll call this R for resource books. Well, we have that many, or that size, whatever you want to call it, if you're looking at your tape diagram, we have 4 times as many fiction books. So it's kind of like a ratio, right? We have 4 to 1 fiction to resource books. Okay. So then we also know that we have half as many nonfiction books as fiction books. Well, we have a tape diagram split into 4 parts for fiction, and we have half as many nonfiction. Half would be 2. And you notice I'm trying to be real careful to make these, pretty close to the right size. So we'll put NF for non-fiction. So now what I'm going to do is I want to look at this and I want to relate it all back to the resource books. Resource books, if that's R, right, then fiction, so I'm going to say resource is R. Fiction is 1, 2, 3, 4 times R, right? So fiction is 4R, and then we have 1, and then here we have 1, 2. So nonfiction would be 2R, 2 times R. Now I can really put these together, because here's the deal. I know my total amount of books, here's my tape diagram for my total amount of books, is 1,400. I know that all of these types of books added together are going to give me my total. So it's the same size, right? So if we have R for our resource books, and then for our fiction, we have 4R, and then for our nonfiction, we have 2R. We know that if we add all these together, we're going to get 1,400. So how many R's are there? We have 1, 2, 3, 4, 5, 6, 7. So now I know that 7R equals 1,400. Don't make the mistake of not counting that R right there. That's 1 R. Even though it just says R, that's 1 R, right? So divide this out, because we know we want to isolate the variable and find out what R actually is. 7R divided by 7, those cancel out. 1,400 divided by 7. 7 goes into 14 2 times. We've got 2 other zeros to bring down. So we end up with R equals 200. So if we pop back down here, how many resource books are there? There's 200 resource books. How many fiction books are there? Well, it's 4R, so that means 4 times 200, because R is 200, so that would be 800 fiction books. And then nonfiction is 2R, or 2 times, instead of R, we know it's 200. So we have 400 nonfiction books. So again, it's a little complicated. There's a lot of steps there, but it's just a matter of looking at what information you have up here in the problem. We had the total, and then we were able to figure out how big each piece of the tape diagram should be based on the fact that resource, 2 times the resource was nonfiction, 4 times the resource was fiction. Put them all together, add them, do a little simple math. There you go. All right, let's do another example together. This one's even a little bit more complicated, but I'm going to show you a little bit different method to solve it. Indiana Ridge Middle School wanted to add a new school sport, so they surveyed the students to determine which sport is most popular. Students were able to choose among soccer, football, I'm going to run out of room, so I'm going to write FB, lacrosse, put LX, or swimming, put SW. The same number of students chose lacrosse and swimming. The number of students who chose soccer was double the number of students who chose lacrosse. The number of students who chose football was triple the number of the students who chose swimming. If 434 students completed the survey, how many students chose each sport? Boy, that's a lot. Here's what we're going to do first. This 434, we're going to ignore that for a minute. But we do need to know our total. So we're going to create a few columns here. So we have soccer, football, lacrosse, swimming, and then our total. So let's just go back to the very beginning. The same number of students chose lacrosse and swimming. Let's make it really easy. Let's say 1 student chose lacrosse, 1 student chose swimming. The number of students who chose soccer was double those who chose lacrosse. Well, if 1 chose lacrosse, double that would be 2. So 2 students chose soccer. The number of students who chose football was triple the number of students who chose swimming. Swimming is 1, so triple means times 3. So football would be 3. Now obviously we know there are more students than this, but what we're essentially doing is creating a ratio, right? Soccer to football to lacrosse to swimming, 2 to 3 to 1 to 1. Our total then would be 2 plus 3 is 5, plus 1 is 6, plus 1 is 7. So our grand total there would be 7. All right. So now that we have this is what's going to help us figure out the entire answer. So we know we don't actually have 7 students. We have 434 students. So now let's look at this as the number of students who wanted swimming. Instead of saying 1, let's just say S, right? 1S. Plus lacrosse is also 1, so that would just also be S. Football would be 3S, right? 3 times the number of students who wanted football. And then soccer would be 2S. So if we add 2 times S plus 3 times S plus S plus S, we're going to get 434. So we know that all of these add up to 7S equals 434. We're going to divide out the 7 to isolate that variable. 7 divided by 7 cancels out. We end up with S equals 434 divided by 7 is going to give us 62. Obviously, we could do the problem to solve that to get to the 62, but I want to make sure we have time on the video. So you would just divide 434 divided by 7. So now you can get rid of all of that. So we have a little space. We know that S equals 62. 1S equals 62. So number of students who want swimming is 62. Number of students who want lacrosse is 62. Our grand total we already know was 434. Football would be 3 times 62, which is 186. And soccer would be 2 times S, or 2 times 62, which would be 124. All right, so we know 124 kids wanted soccer, 186 students wanted football, 62 wanted lacrosse, 62 wanted swimming. To make sure that works, we can add across to make sure that if you add all four of these numbers, you should get 434. And in fact, in this case, we do get 434. So I know that's a lot. There's a lot of steps there. It's a big part of this is just being really patient and thinking about how you can start to attack the problem. We'll look at some more examples and we'll talk more about this in class. Thanks for watching, and I'll talk to you soon.